Hello everyone, welcome to AAT concept video. My name is Narala Siddhartha. My roll number is 20951A6744. My branch is Computer Science Engineering with Data Science as specialization. Today my subject is Data Management and Representation. My topic is Forms of Data. So let's start. I mainly divided the content into three parts. In the first part, we are going to discuss about the basic idea about the data and what the data can be done in order to mold itself for our uses. And in the second part, I am going to discuss about the types of data and its management. In the third part, I am going to discuss about forms of data. So let's begin. So what is data? The basic idea about the data. So data in computing, data is information that has been translated into a form that is efficient for movement or processing. Relative to today's computers and transmission media, data is information converted into binary digital form. It is acceptable for data to be used as a singular subject or a plural subject. Raw data is a term used to describe data in its most basic digital format. The concept of data in the context of computing has its roots in the work of Claude Shannon, an American mathematician known as the father of information theory. He ushered in binary digital concepts based on applying two-value Boolean logic to electronic circuits. Binary digit formats underlie the CPU, semiconductor memories, and disk drivers, as well as many of the peripheral devices common in computing today. Early computer input for both control and data took the form of punch cards followed by magnetic tape and the hard disk. Early on, data's importance in business computing became apparent by the popularity of the terms data processing and electronic data processing. Over the history of corporate computing, specialization occurred and a distinct data profession emerged along with growth of corporate data processing. So let's discuss how the data can be stored in various formats. So computers represent data including video, images, sound and text as binary values using patterns of just two numbers 1 and 0. A bit is the smallest unit of data and represents just a single value. A byte is 8 binary digits along. Storage and memory is measured in megabytes and gigabytes. So these megabytes and gigabytes are used nowadays, but before some years back, before 1 century back, these bytes, gigabytes and megabytes have not been introduced, and they were using kilobytes as their memory units for storing the data. And as the time passes, that value of these memory bytes has been increased for the usage of large memory data. So the units of data measurement continue to grow as the amount of data collected and stored grows. The relatively new term Brontobyte, for example, is the data storage that is equal to 10 to the power of 27 of the bytes. Data can be stored in the file formats as in mainframe system using ISAM and VSAM. Other file formats for data storage, conversion and processing include comma separated values CSV files. These CSV files are mainly used for data sets which can be used to store the data for analysis in the form of rows and columns. So these formats continue to find uses across a variety of machine types, even as more structured data oriented approaches gain footing in corporate computing. Data is critical for any business as it helps them make decisions based on trends, statistical numbers and facts. Due to this importance of data, data science as a multidisciplinary field developed. It utilizes scientific approaches, frameworks, algorithms and procedures to extract insight from a massive amount of data. These days, data science is the backbone of any industry and current trends indicate that it will accumulate even more importance in the coming days. If you want your business to succeed, it is critical that you bank on data science. This article offers you a comprehensive insight into data science. Improve people's lives. Data will help you to improve quality of life for people you support. Improving quality is first and foremost among the reasons why organizations should be using data by allowing you to measure and take action on effective data system can be enabled your organization to improve the quality of people's lives. Make informed decisions. Data is equals to knowledge. Good data provides indisputable evidence while anecdotal evidence, assumptions, or abstract observation might lead to wasted resources due to taking action based on an incorrect conclusion. Stop molehills from turning into mountains. Data allows you to monitor the health of important systems in your organization. By utilizing data for quality monitoring, organizations are able to respond to challenges before they become full blown crises. Effective quality monitoring will allow your organization to be proactive rather than reactive and will support the organization to obtain best practices over time. Get the results you want. Data allows organizations to measure the effectiveness of a given strategy. When the strategies are put into place to overcome a challenge, collecting data will allow you to determine how well your solution is performing and whether or not your approach needs to be tweaked or changed over the long term. Find solutions to the problems. Data allows organizations to more effectively determine the cause of problems. Data allows organizations to visualize relationships between what is happening in different locations, departments, and systems. If the number of medication errors has gone up, is there an issue such as staff turning or vacancy rates that might suggest a cause? Looking at these data points side by side allows us to develop more accurate theories and put into place more effective solutions. So back up your arguments. Data is a key component to system advocacy. Stop the guessing game. Data will help you obtain both good and bad decisions to your stakeholders. Know what you are doing well. Data allows you to replicate areas of strength across your organization. Be strategic in your approaches. Data increases efficiency. Effective data collection and analysis will allow you to direct scarce resources where they are most indeed needed. If an increase in significant incidents is noted in a particular service area, this data can be dissected further to determine whether the increase is widespread or isolated to a particular site. Make the most of your money. Funding is increasingly outcome and data driven. With the shift from the funding that is based on the services provided to the funding that is based on outcomes achieved, it is increasingly important for organizations to implement evidence based practice and develop systems to collect and analyze data. Types of data and its management. So let's discuss about different types of data and how can we manage this data in order to use ourselves for our advantage. So growth of the web and smartphones over the past decades led to surge in digital data creation. Data now includes text, audio and video information as well as log and web activity records. Much of that is unstructured data. The term big data has been used to describe data in the petabyte range or larger. A shorthand take depicts big data with three V's: volumes, variety, and velocity. As web-based e-commerce has spread, big data-driven business models have evolved with the treat data as an asset in itself. Such trends have also spawned greater preoccupation with the social uses of the data and the data privacy. So let's discuss about the different forms of data. So Forms of data. The data is somewhat categorized into many forms. Some of the one of these is qualitative or categorical data. Qualitative or categorical data is the data that cannot be measured or counted in the form of numbers. These types of data are sorted by category, not by numbers. That's why it is also known as categorical data. These data consists of audio, images, symbols, or text. The the gender of a person, that is male, female, or other, is a qualitative data. Qualitative data tells us about the perception of people. Nominal data. Nominal data is used to label variables without any order or quantitative value. The color of hair can be considered nominal data, as one color can be compared with other color. Ordinal data. Ordinal data have natural ordering where a number is present in some kind of order by their position on the scale. These data are used for observation like customer satisfaction, happiness, etc. But we can't do any arithmetic tasks on them. Quantitative data. Quantitative data can be expressed in numerical values, which makes it countable and includes statistical data analysis. These kinds of data are also known as numerical data. It answers the questions like how much, how many, and how often. For example, the price of a phone, the computer's RAM, the height or weight of the person, etc. falls under quantitative data. Discrete data. The term discrete means distinct or separate. The discrete data contain the values that fall under integers or whole numbers. The total number of students in a class is an example of discrete data. Continuous data. Continuous data are in the form of factorial numbers, fractional numbers. It can be the version of an Android phone, the height of a person, the length of an object, etc. Thank you.